All right, let's check out this homework. So we are given that line MQ is parallel to the line NP. I like to highlight those. They are marked as parallel, but I'm going to highlight them anyway. Again, I like to extend them. And for this question, I have 1, 2, 3 different transversals going on. I have a transversal here. So all of the angles bordered by green and yellow are related. I have a transversal here. So any angles that have one green side and one orange side are related. And then I have another transversal here, which means any angles that have one green side and one purple side are related. So I have a lot of different pairs that I could pull from this, and we're going to have to figure out which ones we want. We are given that angle 4 is congruent to angle 3. And we are also given that angle 1 is congruent to angle 5. Sorry, we're not given that. That's what we're trying to prove. Sorry, we're trying to prove that angle 1 is congruent to angle 5. Now, we don't have anything about 5 happening at all right now. But our goal is to be looking at these angles, and we kind of have to bring these into the question. So my first thought is, like, where the heck are 1 and 5 even coming from? Well, 1 is an angle that's yellow and green. So if I look at the picture, is anything else yellow and green? 4 is. So 1 and 4 are really the same. So that I know is the same as a 4. 5 is a yellow and orange angle. And I look at the picture, is anything else yellow and orange? Sorry, yellow and orange, green and orange. 5 is green and orange. Is anything else green and orange? Right here, 3 is green and orange. And they either have to be congruent or supplementary, and looking at them, I'm pretty sure those are congruent. So 5 is the same as 3. And now if I look, there's my given. That 4 and 3, like those are the ones I'm trying to prove are the same. So if I can show that 1 matches 4 and 3 matches 5, since 3 matches 4, I can make this happen. I'm linking things. That makes me think I'm going to be doing some transitive property. Okay, I know I have to bring 3 and 4 into this question somehow and link them to 1 and 4. But I circled 1 and 4. It would be helpful for me to say 1 is congruent to 4. I circled 3 and 5. So it would be helpful for me to say 3 is congruent to 5. And both of those facts come from the parallels. So my given is that MQ is parallel to NP. From that, I'm taking 2 different facts. 1 is congruent to 4, and 3 is congruent to 5. So if I focus on one of them at a time, maybe I say right here that 1 is congruent to 4. 1 and 4. So I get the picture. They're green and yellow. Are they alternate interior, alternate exterior, corresponding, or same side interior? You might have to turn your head. You might have to turn your paper. But those are corresponding angles. So our reason is if parallel lines are cut by a transversal, then corresponding angles are congruent. Then we also know that 4 is congruent to 3. That was given. So if we take these 2 facts and link them together, 1 is congruent to 4, 1 is congruent to 3, sorry, 4 is congruent to 3. That gives us 1 is congruent to 3. Well, our goal is to get 1 congruent to 5. So we need to bring 5 into the picture. Well, our parallels told us that 3, oops, I almost wrote the answer down, that angle 3 was congruent to angle 5. Those angles are green and orange. We go through our relationships: alternate interior, alternate exterior, corresponding, same side interior. Those are alternate interior angles, which means that they are congruent. So there's my reason. And now, since I have 1 is congruent to 3, and 3 is congruent to 5. I can link those together, and I'm left with 1 is congruent to 5. And when we link, our reason is transitive property, not substitution. All right, our second question. AB is parallel to CD. Let's check it out. Here are my lines. Here's my transversal. And BC is parallel to DE. Well, BC started in yellow, so I'm going to put this in yellow. Now, we do have a little bit of a flaw in what I gave you before with my two colors, because those angles are both purple and yellow, which means they are related. But my issue is they are not connected by a single transversal, so we cannot use one of those reasons from our pink sheet. We are going to have to do some linking, because to get from here to here, we do have to hop from one transversal to another. So we are going to have at least 2 steps. And there is more than one way to accomplish this proof. But let's look at what we're asked to prove. We're asked to prove that those angles add up to 180, which does mean that they're supplementary, so we're going to have to bring some supplements into the mix. And we have to find a way to link from this angle of B to this angle of D. How the heck are we going to get there? Well, we need to find an angle that they're both related to. And an angle that they're both related to is right here. This guy. And if that's B degrees and D degrees, I might as well call this one C degrees, because it's at vertex C. We do have more than one way that we can get through this proof. So take a minute, think about your properties, maybe come up with a plan. Okay, so what do I know? I know that B and C are equal. I know that C and D are supplementary. So the things that I'm thinking in my mind are that B equals C. And well, I know that C and D are supplementary. Well, if they're supplementary, that means that C plus D is 180. Well, B and C are the same, so this could be a B. And actually, that's what I'm being asked to prove. So, no, it's not. So we're being asked to prove that B plus D, sorry, C and D are supplementary. B equals C. I'm being silly. B equals C. C and B are the same. So that turns into a B plus D is 180. That's what we're being asked to prove. That makes a lot more sense. And over here, it kind of isn't proof. So we have to make that happen. But there are equal signs, so we are going to have to deal with a little bit of equal to congruence business. So my first given is that AB is parallel to CD. From the purple parallels, I was able to conclude that angle B was congruent to angle C. And those are alternate interiors. So my reason is if parallel lines are cut by a transversal, then alternate interior angles are congruent. And since they are congruent, that does mean that they have to be equal. Now, last lesson we were saying measure of angle B plus equals measure of angle C. We can say that, but the way they use those markings, B degrees is the measure of angle B, and C degrees is the measure of angle C. So we can switch that. And when we go from congruent to equal, our reason is congruent angles are angles with equal measure. So there's that step in my plan. Now I have to try to get my supplementary angles. Well, the supplementary angles, those came from the yellow parallels. So my yellow parallels, we'll make our hints even a little nicer here. My yellow parallels versus my purple parallels. So the yellow parallels tell me that angle C and angle D are supplementary. We haven't had this reason yet, but it is that if two parallel lines are cut by a transversal, then same side interior angles are supplementary. They're supplementary, then they must be equal. Just kidding. They must add up to 180 degrees. Now we have two equations. And I just kind of did exactly what I said we didn't have to do. So we don't have to say measure of angle C and measure of angle D because they gave us those measurements. It's just C plus D is 180. And if B is equal to C, then we can replace this with a B, and we're left with B plus D equals 180, which is what they asked us to prove. The third proof, I'm going to give you the skeleton, but that one I do want you to try on your own, and I actually do think it is a little easier than the previous two.